तो वहां पे फॉरेस्ट्री तो होगा ही नहीं।
क्या सर?
वहाँ फॉरेस्ट्री तो होगा ही नहीं सब्जेक्ट, है ना?
हाँ, फॉरेस्ट्री नहीं है, लेकिन यूनिवर्सिटी कैंपस में चलता है फॉरेस्ट्री, एमएससी फॉरेस्ट्री ओनली।
जी जी। अच्छा अच्छा।
तो इस बार मेरे अंडर पीएचडी भी आ गया था, फिर लोगों ने थोड़ा बवाल क्रिएट कर दिया,
हम्म।
तो इसलिए थोड़ा दिक्कत आ गई, पीएचडी भी यहाँ आ चुका था।
अच्छा अच्छा।
Good morning, everyone. Dear participants, our resource person has already joined and we will start in a couple of minutes. So today is the 7th day of our 21 days training program. And As per the schedule, we have three very important lectures for today. We will start with Shri DP Khali Sahab, who is the senior scientist G at the ICFRE Dehradun, and he will be talking about composite wood technology, efficient wood utilization. It would be followed by Dr. Mohammad Javed Sahab, Senior Research Fellow and Associate Professor at UPM Kuala Lumpur, Malaysia. And his title of presentation is High Impact Research Publications. This have been scheduled in the first half. In the second half, from 16 hours to 16 hours to 17 hours, that means 4 to 5 p.m. Dr. Arun Gupta from UPM Gambang, Malaysia, will be talking about advanced composite biocomposite. So three wonderful lectures by really senior level scientists and academicians will be briefing us, will be taking us on a journey of wood science, as well as on the publications, how to be more efficient in the research publications. So with these words, I welcome you all, and of course, for a warm formal welcome, I invite Dr. Mohammad Nasir to please deliver his formal welcome to DP Khali Sahab. Over to you, Nasir Sahab.
Good morning, everyone. Welcome to you on the 7th day of 21-day training program. Our resource person, as Dr. Maheshwari said, he has already joined. And on behalf of the organizing committee and my own behalf, I welcome you, sir, to the 21-day training program. And just to brief you about the program, sir, there are 34 students are participating, attending this program, and these all are the assistant professors in different universities, different colleges. At the same time, now let me have this opportunity to introduce you as well to the participants. Dr. DP Khali sir is a scientist G, and at composite wood discipline in forest product division of FRI Dehradun. He has 3 decades of research experience in the field of wood composite, and he has published more than 60 research papers in various national and international journals, presented more than 30 research papers in various national and international conferences, and he has guided so far 3 PhD students and maybe around 100 master students in their. He has completed 18 research projects as a PI, as a co-PI, including 7 externally funded projects. At present, he is working as a national project coordinator in ECRIP and as a PI and co-PI in 4 other ECRIP projects. His milestone works are he has developed Compiply using a plantation species like poplar and eucalyptus. He has developed a reconstructed wood from the bamboos, developed methodology of plywood and other composite wood, developed fire retardant, 4 different type of fire retardant used in the preparation of composites from lops and tops of this non-commercial timbers like Emilia, poplar, eucalyptus, and he is a member of Timber Development Association of India. It is published from FRI only, and Indian Academy of Wood Science. He is also a member of Bureau of Indian Standards (BIS) and member of Academic Council of Research Degree Committee and Board of Studies of member of for FRI Dehradun University. So with this brief biodata, and I will not take much time, I would invite him to please continue his presentation. Thank you. Over to you, sir.
Thank you, Dr. Nasir, for such a wonderful introduction. And very good morning to all of you. I will be discussing with you all today on the topic that is composite wood technology, efficient wood utilization. So directly coming to the topic, basically the wood product sector is broadly can be categorized into 2 categories. One we call the primary manufacturing sector, another we call the secondary manufacturing sector. This slide very popular slide. You all must have seen earlier also. So basically, you all know wood is wonderful material. The advantages of wood, the merits of wood, you all know. But here I will be talking the three major disadvantages of the wood as far as utilization is concerned. The number one disadvantage as far as utilization is concerned, wood has got lot of variability. In other terms, we call wood as an isotropic material. An isotropic material means its property changes with direction. You must have seen that its property from pitch to periphery, even from bottom to top, it varies. So this nature we call the anisotropic nature. So this is the, as far as utilization is concerned, this is the one disadvantage. Another disadvantage, wood is not dimensionally stable material. What does it mean? When wood come in contact with moisture, it swells, and if you remove the moisture, it shrinks. So it changes its dimension when it comes with contact with moisture. So that is the second disadvantage. Third disadvantage is we are using wood in a solid form, lot of wastages are there. That is the utilization yield. So maximum utilization yield if we use wood in the form of solid form or in the form of timber, maximum up to 35 to 40% utilization is here. Remaining can be wasted or can be used for some other inferior purpose. So that's why nowadays the composite wood utilization is being promoted. More focus is towards use or convert wood in the form of composite and then can be utilized. Because all these three major disadvantages which wood has got can be addressed if we constitute it in the form of composite. The variability can be minimized and the utilization yield can be maximized even up to the 100%. The first example of the composite is the plywood. So if we are using in the solid form, in the timber form, up to 35 to 40% utilization is here. If we use wood in the form of plywood, we can increase it up to 55 to 60%. And nowadays, because a lot of advancements are there in the machinery technology also, one we call the spindle-less spinning blade. So using those kind of spinning blades, up to 60 to 65% yield utilization is here. So from 35 to 65, the yield is here. But if we convert, ideally, the wood composites are those composites. The examples are particle board, fiber board. So in that case, ideally we can say that 100% utilization is here. Even the other lignocellulose material also, any material which has got lignocellulose, whether that is out of wood.
Sir, I would interrupt you. I will interrupt you, sir. Just a minute, sir. I think your slide is not moving, sir.
Okay. Yeah, it is moving now.
Yes.
Yeah, I have not moved. Yeah, I have not moved.
Okay.
So for addressing those three major disadvantages, the composite, we can use lignocellulose material in the form of composite. Now the definition, technically somebody asked that, what is the definition of composite? You all know that when two or more dissimilar materials are mixed together and a new material form, that material we call the composite. So here, wood composite is nothing but we are mixing the lignocellulosic material with resin and some additives for modifying the end product certain property. When all these three things are mixed together, that process we call the resination, and these are reconstituted in the form of some product. So that product is known as composite, wood composite. Okay, so yeah. So the history, if we see the history again, the usage of wood composites, it goes back to the early mankind. But the major categorization of the composites can be three types. The first one where the composites we are making using the veneer. Again, veneer are nothing but these are the very thin sheet of the wood material. So if the constituent material is in the form of veneer or lamella, so out of that, if you are making composites, so those, that is the first type of composite. If second type of composite where the constituent material is in the form of particles, the examples of those are the particle board. Third one are when the constituent material is in the form of fiber. So those out, if we are making composites out of those fibers, so that is the third category. So these are the major category of composites: plywood, particle board, and fiber board. But if we see the market share of these composites, still market is dominated by the particle board. As far as our country is concerned, India is concerned, the market is still dominated by the plywood usage only. 75 to 80% usage out of whatever composites are being used, that is plywood only. Particle board only 10 to 15% utilization, that is market share is there, and MDF is still only 5 to 10%. What is the reason? In the coming slides, I will be discussing with you. Still, in our country, the major wood consumer in India are the plywood industry only. Earlier, that you all know that this green filing ban when it started. So before that, the plywood industry are mostly dependent on the forest trees only. So that's why whatever commercially available trees are available, those can be utilized for manufacturing of the plywood. So earlier mainly acacia species were being used, West Rose, Alvesia species were used, and even Cryptocarpus species, because Cryptocarpus species were available in plenty that time. So those were being converted to the veneer, and then those veneer were being used for manufacturing of the plywood. But after green felling, that is ban on green felling, now there are no wood species are available from the forest. So that's why plywood industry are only dependent on the plantation wood species. So as far as northern India is concerned, in the northern India, the plantation species mostly are available, that is poplar and eucalyptus. So that's why the plywood nowadays, plywood industry, they are using the poplar and eucalyptus for manufacturing of the plywood. And in the southern India, even rubber wood is also available. So rubber wood is also being used for manufacturing of the plywood. But not only these three species, other whatever wood material is available, those also can be utilized for manufacturing of the plywood. But mostly these three species are available, which are being used by the plywood industry for manufacturing of the plywood. Now the definition, as far as definition of plywood is concerned, so three important points are there for plywood definition. That number one, plywood is made of veneer. Veneer are nothing but the very thin sheet of the wood material. Second point, that two adjacent veneer are always perpendicular to each other. And third important point, as far as plywood is concerned, manufacturing of plywood is concerned, that is always for balanced construction, odd number of veneers are being used for manufacturing of the plywood. Okay, now types of plywood, again for aesthetic purpose. If on the top and bottom we are using some decorative veneer, so those we call the decorative plywood, and otherwise second type are the commercial plywood. Again, commercial plywood, mostly the 75 to 80% production in our country is general purpose plywood. In the bracket, I have written the IS specification. General purpose plywood IS specification is 303, and all these specifications are freely available on net. If anybody is interested to know more about individual plywood, can be downloaded on the through internet. These are available. General purpose plywood again can be categorized into two categories depending on where it is being used. If it is being used for the interior purpose, so interior grade plywood, and if it is being used for the exterior purpose, that we call the exterior grade plywood. Now, interior grade, exterior grade, on which aspect it depends, what kind of adhesive we are using. So that also I will be discussing in brief later on. Then another type, shuttering. Purpose plywood is again for certain purposes the plywood is being used. So for that purpose, this is being manufactured. Structured plywood, although IS specification is here, but no industry in our country, nobody is manufacturing this because there is no demand at all right now in our country. But still, for academic interest and IS specification is there. Marine grade purpose plywood means this kind of plywood can be utilized for extreme conditions, like in the dockyard usage or in the marine conditions which are being used. Again, next two are again for academic purpose only. Preservative treated plywood and fire retardant treated plywood. These are also available and are being manufactured in our country. Now, why still plywood is dominated? Why the market share of plywood is still dominated? There are plenty of reasons. The first reason is plywood is highly stable panel, and because the earliest composite which got developed in our country is the plywood only, and most of the users are familiar with plywood. Lot of awareness of usage of the plywood is there, so that's why still this market is dominated by plywood. Second important aspect that is the dimensional stability of aspect. As far as particle board and fiber board are concerned, if are not being used properly, those are not dimensional stable because moisture used to get penetrated through its edges. And if moisture gets penetrated inside those particle board, then what happens? It swells. So about the plywood is more approximately 7 times more resistant to thickness swell than the substitute wood-based panel. And if at all some moisture plywood has absorbed, once it dries up, it regains its original shape and size. Second important aspect, that is the strength aspect. So all four strength aspects, that is bending strength, tension strength, compression strength, and planar shear. It is more stronger than other substitute wood-based panels. So this is the another important aspect. The third important aspect, highly impact resistant. Plywood is highly impact resistant. So due to these reasons, still market is dominated by plywood, the usage of the plywood. These are some of the advantages you all must be knowing because the plywood, whatever size you require in the market, in various sizes it is available, starting from 3 feet by 6 feet, even up to 12 by 24 feet size plywood are available. Even if demands are there, bigger than the size of 20 to 24 can be manufactured. Dimensionally stable, distributed strength, non-splitting quality, high strength to weight ratio. So all these you in different shapes and size you can manufacture of plywood. These are the stages of plywood. In brief, I will be discussing with you about the stages of plywood. The first one is the important one, selection of logs and their storage. Okay, so this is when the plywood industry was dependent on the forest wood. So that time, if plenty of raw material is available, so we have the choice of selection of the material. But nowadays, we don't have any choice. Whatever plantation timber is available, that has to be converted to veneer and has to be converted to the plywood. But if at all choices are there, so the log should be straight, cylindrical, and free from heat. Storage should be such that no ash cracking should be there. If at all ash cracking are there, those have to be minimized. And if cracks have been developed, so while breaking, the quality, while peeling, the quality of veneer will not be as desired. And after felling of the log, the moisture, one has to try to avoid moisture loss. If more moisture loss is there, the quality of veneer, then again we have to reintroduce the moisture inside the log. That's why during storage, it has to be stored in the log pond. If at all it has dried, then steaming is required. In the log pond, the log has to be steamed. Now, how long it has to be steamed, the duration, all these depends on what kind of wood is there. how much specific gravity it has got. It's very hardwood species, then longer duration, and for longer duration, the steel is required. If longer diameter is here, again, it depends on that also. How much moisture content already it has got. Moisture gradient, how much it has got. So all the temperature and duration of heating depends on these four aspects. Okay, once our log is ready for peeling, then in the photograph you can see these are the peeling leaves. These are the spindle peeling leaves. Log dia. Uh, log dia are those when such kind of peeling leaves are being utilized. So here you can see that in between two spindles, the log is fixed with the help of hooks. Then a knife come on contact with that log, and with the help of that spindle, the log gets rotated. Even RPM also can be controlled. So if it is getting rotated and that knife is on close, if that knife is on close contact with the log, so what will happen? On the other side, a continuous wood heat will come out, and that continuous heat is nothing but the veneer. Now, the quality of veneer depends on, again, setting of the machine, how much gas and knife angle, depending on different wood species. For hardwood species, different knife angle and gas setting is required. Then, depending on that thickness, how much thick veneer we require. So, all setting has to be done here at the time of peeling. This type of peeling we call the rotary peeling. This is the peeling rotary. With the help of this rotary peeling, we are generating the getting the veneer. So peeling with the help of peeling. Other way of manufacturing veneer is the slicing. With the help of slicing also. The slicers are also there, but with the help of slicers, we can generate the decorative veneer. But commercial veneer can be generated or can be manufactured with the help of these type of rotary peeling. But nowadays there are spindle-less peeling lathes also. So this is another details of the controls in the cutting operation. In a schematic diagram, you can see here at the top, this is the slicer. With the help of slicer, the log. So here, if we are trying to generate manufacture the decorative veneer, the log first has to be converted to the flip or in the form of flipper only. Then only we can get this decorative veneer. But in this case, in the peeling, in the rotary peeling lathe, the log first has to debark and directly it can be put in the peeling lathe and the veneer can be generated. This is another schematic view. You can see central rotary cut this way. The knife is coming in contact with the log and a continuous piece of veneer is coming out. And so these are the schematic diagram I am showing you. Now, once veneer has been generated. So there are two ways. If very good cylindrical log we have got, then each side of veneer, continuous piece of wood will come out. But ultimately we have to make the 6 feet ply we have to make. So we have to cut the veneer in that side. So cutting is process. Converting bigger size of veneer into the smaller size of veneer, that process we call the veneer clipping process. From bigger to smaller, that is the veneer clipping. But if we have to make bigger size from smaller size, that process we call the splicing. Bigger to smaller clipping and smaller to bigger is the splicing. So here this is the photograph of the splicing. So here you can see that small size with the help of this slicer, the zigzag shape that adhesive is spread over the edges of the two veneers, and then with the help of this roller, those two edges are being joined together. So this process we call the veneer splicing. Now then once veneer has been generated, then handling of veneer, because earlier diplocarpus veneers were being used, so diplocarpus species can be used as a paste and top and bottom, as a top and bottom veneer also, as a core veneer also. So immediately after sealing, those veneer can be categorized, whether some veneer can be used for the face or the defected one can be used for the core. But if you are using poplar and eucalyptus, then this classifying or grading is not required, because poplar and eucalyptus are being used for the core purpose only. These are not being used for the face and back. So face and back, still in our country, the cryptocarpus species is being used. Some nowadays raccoon and some other species are being veneers are being imported from the abroad. Those are being used for face and back veneer. Nowadays we are working here at FRI media media. We are trying to convert media for face veneer and back veneer. So grading, once grading has been done, then applying the adhesive on the surface of the veneer. Because ultimately those veneer has to be joined together, has to be bonded together. So how to apply the adhesive on the surface of veneer? There are various ways, but in our country, the major method is the this glue, application of the glue with the help of glue spreader. So again, you can see in the photograph, this is nothing but a sugar cane crushing machine kind of machine it has got. At the bottom, that tank of the adhesive used to be here, because these two rollers are rotating anti-clockwise. So bottom will hit in the adhesive and will take the adhesive. That adhesive will get applied on the surface of that roller, and in that process, on the upper roller also adhesive will get applied, and then the veneer can be passed through these two. And once veneer has been passed through these two rollers, the adhesive will get applied on the whole surface of the veneer. So that is the easiest and the cheapest way of applying the adhesive on the surface of the veneer. Other way like spreading, brushing, various other ways are also there. But at this step, the pH control becomes very important. So that's why the quality assurance here in the industry, the very that same is here. So anybody can make composites, anybody can make plywood, but the quality plywood can be made by trained person only. So here the little that knowledge of all these parameters required. So once adhesive has been applied, then assembly here in the slide you can see these are the press, hydraulic press, a multi-opening press, top and bottom. This is a small press we are having here in our lab, 2 feet by 2 feet. We have to be 2 feet by 2 feet from this only to this press. This is the bottom one, industrial press, 4 by 8 feet multi-opening press. Here in the lab we have the single opening press and multi-opening small press. So assembly means again we have to arrange the veneer in such a way that two adjacent veneers are always perpendicular to each other. So the veneer which has got the adhesive on the top surface only. So those veneers we call the even number veneer. So top, suppose we call the number 1 veneer. So that veneer will not have any adhesive at all. Second number veneer will have the adhesive on both the surface. Then third veneer will not have any adhesive at all. So top and third will have same direction, while second number veneer will have the perpendicular direction. So that's why always top and bottom one. If 7 veneer we are having, so both surface will have the same direction. That's why the balanced construction. This type of construction we call the balanced construction. So always for manufacturing of the plywood, odd number of veneers are used. So again, these are some technical terms. So I will not go in detail. This is a single press, single opening press, continuous press, industrial press. So industry they are using this one. So semi automatic. Here conveyor belts are there. Even using conveyor belt loading, automatic loading and automatic unloading can be done. Once plywood, because we are research organization, so once plywood has been prepared, or any for that matter any composite has been prepared, so for quality assurance, random that sample selection is required. So sample has to be selected and those has to be tested. So laboratory testing is actually here. So this is a tensile testing machine. You can see here a very primitive type. We have here computerized also, but for teaching purpose, because here we can show the how much load is being applied, at what load, how much deflection is there. So all these things can be seen. So for teaching purpose, this one is the best one. Now, what kind of test has to be performed? It depends on where our product we are going to use. Depending on end use, that particular test has to be performed. For insulation purpose, the plywood is being manufactured, so related to insulation. If it is being used for semi-structural purpose, then strength as well as durability. For furniture manufacturing, if it is being used, then screw holding, nail holding, all those kind of. So depending on end usage, the test has to be performed. So now this is the stages of plywood manufacture. So in a flow chart, storage of log, preparation of veneer, two way of preparation, peeling, slicing, two ways are there, then clipping or splicing. If bigger veneers are there, converting it into smaller, clipping, then from smaller to bigger, that is the slicing. The drying of veneers becomes very important because adhesive bonding can be the ideal, the good strength we can achieve if moisture content is below 12%. Then gluing of veneer, assembly of glue veneer, pressing of assembly. Now cold pressing and hot pressing. It depends on what kind of adhesive we are using. Now here cold pressing does not mean freezing temperature. Cold pressing here means that room temperature pressing. So even if we are using the US, area formaldehyde adhesive, so at room temperature also curing can be taken place. Now here curing means hacking of the adhesive. So curing means bond formation. If we are establishing the bond, that process we call the curing. So even if we are using urea formaldehyde adhesive, the cold pressing can be done. But in the industry, mostly hot pressing is the preferred one. Then conditioning, finishing, packaging, and marketing. So this is the manufacturing process of the plywood. Same way we can manufacture the other composite saws. Only preparation of the raw material. In the plywood, the log we are converting into the veneer, then veneer are being used for manufacturing of the plywood. If we have to make particle board, first the lignocellulosic material has to be converted into the particles, then the adhesive has to be applied on the surface of the particles, then those has to be reconstituted. Same kind of the press, using same kind of the press in the form of the particle. Similarly, in the case of the fiber board, the lignocellulosic material has to be converted to the fiber using various punching process are here. But for manufacturing of the medium density fiber board and hard board, we use the thermomechanical pulping process. There are other like chemical pulping processes here. Lignocellulosic material can be converted into the fiber using the chemical process, but that is adopted in the paper industry. But as far as fiber board industry, here the pulping process, the preferred one is the thermomechanical pulping process. So once that raw material is ready, so after that applying or adding the adhesive can be substituted in the final product. Okay, now what is the adhesive? Again, because for quality assurance, for quality, whatever desired quality, we have to make our composite. The quality depends on what kind of adhesive we are. Again, adhesive is nothing but the material which binds together the lignocellulosic material. It can be categorized into two categories depending on the origin: natural glue and the synthetic glue. Nowadays, nobody are using natural glue. Mostly the synthetic resins are being used as far as our country is concerned. But with synthetic glue, lot of environmental concerns are there. So, lot of R&D is being carried out. See whether we can switch over from synthetic glue to other glue system like Dr. Nasir has done some work on binderless system also. So similarly, that is from nature also lignin-based glues are there, tannin-based glues are there. So those also can be utilized. But still, as far as our country is concerned, for interior purpose, amino-based adhesives are being used, and for exterior purpose, phenolic-based adhesives are being used. Exterior-grade plywood are being manufactured. For that, phenolic formaldehyde adhesive can be used, and interior-grade plywood, aminoplastic, that is urea formaldehyde adhesive. Grades of adhesive also interior grade, exterior grade. Now this is last one is very important now. Boiling water proof, boiling water resistant, moisture resistant. The adhesive can be categorized into three categories: BWP, BWR, and MR. So MR is the inferior one, which can be used for the interior purpose. With MR grade adhesive, we have used for manufacturing of the plywood. That plywood cannot be used for the exterior grade at all. Only interior grade. It can survive in the dry conditions. If some moisture is come in contact with moisture, it may get disintegrated. Boiling water resistant, it can be used for the exterior purpose. And BWP, that is boiling water proof, can be used for the extreme conditions, like for shuttering purpose plywood. This BWP for marine grade plywood, this BWP adhesive can be. Now, how to assess which type of adhesive is the BWP, which type of adhesive is the PWR, which type is the MR. This is the slide. As far as industry as well as user is concerned, this is very important slide. Characteristics of different type of synthetic resin adhesive of plywood. Again, the IS specification is it is available on the net. So glue shear strength. Once we have made plywood using that particular type of adhesive, then that plywood has to be tested for the glue shear strength. Now, what kind of specimen has to be prepared? This is the sample specimen. You can see here. This is glue shear strength test specimen. This is a three veneer ply. You can see the top, bottom, and the two veneers. Only three veneers are used here. This is the edge glue. At the middle, this is the veneer. The adhesive has been applied on the both surfaces of the veneer. So this type of specimen is prepared, and then this specimen is subjected for the glue shear strength. In the previous slides, I have shown you that pad tensile strength in between those two dots. This sample is fixed, and then the load, gradual load is applied, and how much this sample is able to withstand load. If the average is more than 135 in the dry condition, then we can say that this adhesive meets the criteria of BW. Now, what does average and individual mean? As you all know that, because wood is the biological material, so to cater the variability, at least 6 samples are tested. So average of 6 samples is 135. It should be more than 135. And out of those 6 samples, no one should have less than 110 kg. So how much that small, how much area this load should be withstand 1 square inch. Only 1 square inch area should be able to withstand more than 135 kg. And in the case of BWP. Similarly, in the case of BWR also, in the case of MR, because it is being used for the interior purpose, so 100 kg only, individual 80 kg. Now, this is for the test of the strength. How much strength it has got. Now, how to test durability? So, for durability, these two tests have been simulated in the lab, and some accelerated tests. Now, first one is the wet test. What does wet test mean? For BWP, those kind of samples, what I have shown you in the next slide, are kept in the boiling water for 72 hours. So after boiling those samples 72 hours, again those samples are subjected for test in the glue shear strength. If those are able to withstand more than 100 kg, then we say that it meets our BWP. For BWR grade 8 hours 20, for MR grade 3 hours 60 degrees Celsius and 3 hours heating on, and should be able to meet this criteria. If able to meet, then only we can say that it is meeting our wet condition. Psychological condition. Now again, this is simulated in the lab. Here, what happens? The sawdust, the Bombay Siba sawdust, is used in that the commonly available spores of hunger, what we were commonly earlier, are introduced in that. And the saturation level, sugar level, can at it, the saturation up to 95%. Once it's converted completely into mycelium, then the samples are put in that condition, in that damp and moist condition, at least for 21 days, for 3 weeks. And then those samples are subjected. And if we meet these criteria, then only we say that our adhesive meets the criteria. So you can see that if any plywood is ISI marked, then it should have very good quality. Even moisture resistant also. Moisture resistant also, it should withstand 3 hours warm water dipping test. Then only that ply can have the ISI. So for academic as well as for quality assurance, this is essential one which I have shown you. Now this is we call the diagnostic slide. This is the diagnostic slide. I can show you how to where the failure, what kind of failure has occurred, what has gone wrong during manufacturing. So for industry purpose and for quality assurance, it becomes very important. The topmost you can see the green one is the adhesive layer, the yellow one is the linear wood. If in the wood failure is taking place, so this is a structural failure. So this is the process due to process parameters. Somewhere we have done wrong with our process parameters. Whether we have applied less pressure or temperature is not sufficient, something related with process parameters. So second one here, non-compatibility. Used to adhesive failure is here. That is compatibility is not here. Adhesive is not compatible with wood. The third way failure, if we are able to see the third failure, means wood failure has taken. So either we have applied more amount of the adhesive, or in the adhesive itself some problem. And so that's why we call it diagnostic. Now earlier testing method or the lab purpose I have given, but in the industry they cannot have the UTM, universal testing machine they cannot have for their quality assurance. So this is the for testing the quality assurance as far as industry is concerned. So they can do it easily in their industry. Having a small kind of knife, the photograph I will be showing what kind of knife we can use. So they can boil using any water bath or even cooker also. So they can boil it 6 cycles for GWP, cycles consisting of 8 hours boiling in water and thereafter drying at 65 degrees for 16 hours. Such type of 6 cycles they have to perform and then see whether veneers are getting disintegrated or not. And then forcefully inserting in between 2 veneers the knife. If they are not, this criteria is meets the GWP. Similarly, for GWR, 3 cycles has to be performed. And for MR, 3 cycles, but the conditions of cycle is different. We are only dipping 3 hours warm water and then drying 8 hours drying. And if it meets the criteria, then we say that the adhesive, the proper adhesive is being. So this is for the industrial purpose. All these details I have given. Now, what kind of knife? Hopefully, either one of. Again, the details has been given in the IS specification. So either of knife can be used for hopefully separating 2 adjacent veneers. Okay. Now, for general purpose, that much is required. Adhesive becomes very important. But if you are making the marine grade and concrete shuttering grade plywood, for that, then treatment becomes also becomes very important. Because ultimately, here wood also we are using, and that plywood is going to be used in the marine conditions where it is in contact with number of borers and the microorganisms also. So that wood part can be eaten away. So that's why the treatment is essential. And treatment, pressure impregnation treatment is essential because this much retention can be achieved only with the help of pressure treatment method. And all these preservatives you must be aware about CCA, CCD. So still are being used in our country, although CCA is banned abroad, but in our country is still being used. But in our institute now we have developed alternatives to CCA also, GWOC. Recently we have introduced that GWOC preservative in the IS specification also. So that now CCA will be going to replaced by GWOC, but other conditions are similar. Tensile strength becomes very important, and other than huge strength, tensile strength also becomes very important. MOR, MOE becomes very important. What should be the criteria? Again, I am not going to discuss it because all these are here in the IS specification. How much threshold limit should be there? It is given there. Then the another type is the block board. So plywood made of all veneer. So up to 18 mm, if we require the 18 mm thickness, we can use the all veneer built up. But if we require 25 mm panel, then if we are going to use, we are going to increase number of veneer, what will happen? The material will become heavier and expensive also. So that's why in between, if we are using the wooden sheet, then at the top and top and bottom we are using the veneer, such type of composite we call the block board. So again, types of the block board, decorative is on the feet and back, decorative veneers are used. Then commercial, again interior and exterior depends on what kind of energy we are using. Again, these are the different built up how to make the usage. You all know usage of all these composites, cabinet making, all general purpose can be used, but up to semi-structural purpose only, all these composites can be used. Non-structural and semi-structural purpose. These composites cannot be used for the structural purpose. For the structural purpose, other type of composites like LVL, laminated veneers are there, which can be used for the structural purpose. Then glue lines are there, CLP are there. So those type of new modern composites, those are being used for the structural purpose. Now coming to the technology which we have developed here in the institute. I think how much time I have? Another 10 minutes. I will try to summarize all these technologies in 10 minutes. So this is the one technology which we have developed here in FRA, CombiPly. Now what does CombiPly mean? Here earlier, what was happening? The plywood were being used by were being manufactured using the single species, either discocarpus species, poplar species. But what happens if poplar we are using, only poplar wood we are using? As you all know, poplar has got very low density. So we are not able to achieve the desired state. MOE, MOR cannot be, the desired MOE, MOR cannot be achieved. So the quality of the plywood using only poplar is very inferior. But the poplar has got one very good quality, that it has very high glue. It can glue together any material very tightly. The glueability is. But as far as eucalyptus is concerned, it is very poor as far as glueability is concerned. But strength, as you all know, the density of eucalyptus is quite high. So that's why the strength is more. So what we have done in this technology, we have used the combination of these things. If we put eucalyptus veneer in between two poplar veneer, so those two poplar veneer will glue together eucalyptus tightly. And it's because we have inserted the eucalyptus veneer inside the in between two poplar veneer, that will provide the desired ammonia and MOR. So now, as far as North India is concerned, Yamunanagar, in the North India, Yamunanagar is the major hub of the plywood manufacturing. There are more than 500, nowadays 300 are here. Earlier around 500 industries were there, but some of them are shut down now. So around 300 plywood manufacturing units are there. So they are now only manufacturing this type of plywood, CombiPly. In the industry, they call it alternate ply. So alternate ply and CombiPly is same. Alternate is nothing but the CombiPly. Now, as we are discussing that plywood industry, they are only dependent nowadays on poplar and eucalyptus. So here in our institute, Recently, we have developed 10 different varieties of media dubia also, and it is released also. So now alternative good species also available. Our institute is promoting media dubia plantation also throughout the country, and we have worked on that, and very good quality of plywood can be made out of media dubia. We are working on this species for face veneer. So this is the that trial we have done all the media. You can see here. This is the peeling, the spindle-less peeling lathe. Here the industry, one of the industry in Yamunanagar. This is the spindle-less peeling lathe. We are assessing the quality of the media. So all these quality measures. This is our our pilot plant only. So you must be knowing that the first plywood pilot plant in our country was got established FRI. So from here only then in the northeastern state, the plywood industry got established. So then the third technology is the combi LVR. So combi ply we cannot use for the structural purpose. This is the combi LVR, combi laminated veneer number. This can be used for the structural purpose. Structural purpose, I mean to say that where the heavy load is going to be applied for beam, for column, for bridges. So those kind of use we call the structural purpose. So this also we got developed here. Again, using the poplar and eucalyptus. If you see the property of poplar cannot be used for any purpose, but if it is being reconstituted in the form of combi LVL, can be used for such a high-end usage. So this is the combi LVL. This is our pilot scale trial again in Yamunanagar. Here in the lab, we did all R&D, and then we for pilot scale trial. This is done in Yamunanagar. This is the pilot scale trial. All when we introduce this, then it's in the media also. Okay. And even these kind of products also we can out of LVL. Even talker, tabletop, you can see very good that top look also it has got very good aesthetic look. Now this is the fourth technology on which we are working now, the radio frequency curing. Till now in our country, the composites are being manufactured using the conventional method. Conventional method, what happens? Two plates are there, those two plates are heated, and in between we are putting our assembly, and heat is being transferred from those two plates to the core of the our product. So because from top to core or from bottom to core, it takes certain duration of time. Due to that, the gradient, due to heat gradient, non-uniformity of the product quality generally used to occur. And then the longer duration of time for curing or for bond formation or for manufacturing, long duration of time generally used to require. So in this case, again, radio frequency curing of adhesive, this is very rapid and uniform curing of adhesive method. And here for plywood manufacturing, all process parameters we have already optimized. And nowadays, the ongoing project, that is Eclipse project, which I am handling, in that I am trying to optimize the process parameter for the particle board and fiber board. So this is the same. Again, the press is more or less same. Hydraulic press. Only we have removed all plates in between. Single opening is there, and in between you can see in between this is the 12 press. In between you can see this is the radio frequency sensor. So with the help of this, again all process parameters we have optimized. This is the another technology we have right now as far as particle board and fiber boards are concerned. Again, in these nanoparticles or even microparticles also we have used for improving the quality of the composite, specifically the particle board. This is the another technology from the bamboo, even from the lantana also. These structure reconstituted wood we have developed. This is another technology, and with the help of the knobs and tops, all these can be used for development of this kind of product. Again, this type of product can be used for the structural purpose. Again, very simple method of manufacturing. This is again bamboo, because already you have gone through this one, so I am not going to discuss this one. This is lantana. Using the lantana, you can see here. This is the lantana. this lantana can be converted into such a valuable product. And technology is very simple. Okay, so that's all. Thank you. Thanks a lot for your patient sharing. That's all. So we'll have, I think, another 5 minutes for discussion. If any questions are there, you are welcome. Over to you.
Thank you.
Nasir.
Thank you very much, sir. Oh, it was really a great presentation, sir. You have covered, I would say that it was A to Z in composite, sir. You have covered almost everything in plywood, from manufacturing to processing to, the testing also. You have covered that part. And it was a really very extensive, elaborative presentation it was. So I hope that those who are not even dealing with the forest products utilization, they must have also, have understood it, the process completely. This how the plywood is manufactured, and how we do the testings and all that. And after in the last, you compared the other composite food products, with the processing method of plywood. That was really, a great presentation, sir. So now the floor is open for the question answer. If anyone, we do have some question in the chat box, but if anyone wants to ask question directly to Khali sir, you are, open to, please. Dr. Chandrakant, want to ask question? Please, Chandrakant, go ahead.
Good morning, sir.
Good morning, Chandrakant. How are you? After a long time, I'm glad to see you.
Yes, sir. Sir, I am absolutely fine. So it was really a very great lecture, and everything is all aspects was covered. So, sir, I have just one query. As we know that the bamboo is gaining very prime importance. So, is it means bamboo is suitable for the wood composite or not? If suitable, so which species we can prefer for the wood composite? Bamboo species.
Yeah, good one. Yeah, so composite, yeah, any species. Now again, here, what happens? The specific for composite situation is that the material should be bulk. If we have plenty of material, that can be converted into the composite. In bamboo species can be the polymorpha we have used for composite manufacturing, then gigantic, very good species for manufacturing. So depends on how much availability is here. Although dendrocalmus strictus also can be converted into the composite, but it has other uses also. So those materials which does not have any other uses can be utilized for making of the composite. So because it depends on the what kind of process parameters we are handling. So any species for that matter can be used for composite.
So basically, thank you, sir. Basically, in Bundelkhand region, Dendrocalmus strictus is very prevalent. This region is dominated by strictus. So means we can utilize the strictus also for the wood composite.
Plenty it can be, certainly using that structured wood I have shown you, that is made of strictus only. So using structure only we have made the reconstituted wood.
Thank you so much, sir. And it's really very nice to see you, sir, after a long time. Thank you, sir.
Okay, sir, we any more question from the participant? Please ask.
I think I have seen Ravi also. Ravi Bhardwaj.
Yes, sir, Ravi Bhardwaj is also there, sir. He is a participant now.
Okay. Hello,
Ravi Bhardwaj, please ask question. Okay, there are some questions in the chat box, sir. Dr. Shyama Parveen has asked, sir, may I know about the perspective of plywood industry in region like Bundelkhand, where we are emphasizing on growing species like media, dubia, and even poplar?
Yeah, certainly. Again, it depends on, because the cost of final product depends on the cost of the raw material. If plantation is there because again transport cost is major hindrance. So within periphery of that particular industry, around 20 to 50 kilometer periphery, if plenty of plantations are there, then it is sustainable. So as you are saying that Media Dutia plantation is being raised now in the Bundelkhand region, so in future certainly the plywood industry has got major and it's taken care of.
One more question. Actually, I have also one question, sir.
Right.
It is about the combi ply, sir. You were discussing about the combi LVL. So I'm just curious that the thickness becomes very high when we are making a combi LVL. So the thickness of the whole ply, it is actually becomes very high. So when we go for the pressing and we give the temperature, so it takes time to reach to cure it to cure the core of the the LVL. So how we protect the surface from burning? Means if we will keep on giving temperature, the surface will start burning. So how do we manage it?
Yeah, using the conventional method, the 25 mm up to 25 mm is okay. So if thicker panel you have to lay, then the radio frequency curing, the other technology I was showing you, that is
Yes,
the
yes,
recommended one, radio frequency
yes.
curing. Because in the radio frequency curing, what happens, the energy gets immediately transferred simultaneously throughout where your adhesive is applied. So in that, then
Okay,
no
okay.
energy loss is there and uniformity can be maintained. So up to 25 mm is okay using the conventional method.
Okay, sir. Great, sir. Thank you, sir. Any more question? Dr. Amarjit, you have any question? One more question. Sir, it is in the chat box. Okay. While making combi ply, is there any compatibility issue comes? That is the one question. What are the precautions one can have? That is another thing, question.
Yeah, certainly compatibility issues are there. That's why we call the optimization process. The process parameter has to be optimized. If at all some compatibility issues are there, then we have to rework with adhesive and then the process parameters have to be optimized. So those two things have to be taken care of.
And one more question. That is actually it is the last question. If do we are still using? Are we still using the CCA and CCB as a preservative?
Yeah, that's what, that time also, although it is banned abroad, but in our country still these are being used. But for CCA, CCB, we have now developed another preservative, that is the G-box. We have patented also, and now it is introduced in the IS specification also. So alternative is also there. If somebody aware about that can use. But in our country, still means most of the industry, they are not using at all, even CCA also. Even CCB also, they are not using. Up to some extent, boric and borax, that boric acid and borax, that combination, they are using.
Okay, sir. Thank you. Dr. Joseph is saying that it was a nice presentation, sir. And Dr. Saswat Naik. Dr. Saswat Naik has asked one question, sir. Wait. What is the prospect of Milia Azadi Act for plywood?
Yeah, Milia, but that is good species. That is good species for manufacturing of the plywood. Again, depends on the log size and shape. Because for peeling relatively cylindrical log is required. So if it is not cylindrical, then converting it into linear becomes little difficult and lot of wastage will be there. So if cylindrical logs are there, so that any commercial, for that matter, any commercially available wood species can be converted into slides.
Good. Thank you, sir. So the question from the chat box is over. If still any participant wants to ask, anyone? Okay, sir. So now we will end the session here, sir. I think it was really a very interactive, sir. People, like the presentation, and I personally, I would say that this is a complete package. And if means if I would get it, I would, if I would give it to the students, they will understand completely by their own. We don't need to, even explain them. So thank you very much, sir. Now we are at the end of the session. So I would invite Dr. Aishwarya Maheshwari to please give a formal vote of thanks. Thank you, sir.
Thank you.
Thank you, Dr. Nasir. Sir, our participants were listening with full focus, and their, questions are representing that they were having a lot of questions which they have asked. Might be they are too shy to ask them directly. That is why they have put it in the chat box. But one thing I would like to inform you, sir, that we have a full variety of, diverse variety of participants from different backgrounds. We have wildlifers, we have FPU, of course, agroforestry, and from horticulture as well, and agricultural background. One of the best qualities which we have, encountered in you is basically how to communicate the science with very simple words that everyone can understand. And that's what Dr. Nasir has clearly mentioned, that we have a recording of all the presentation, which would be, telecasted to the students later on, so that they can understand at a very early stage the concepts which you have clarified in your lecture. So on behalf of the organizing committee and my own behalf, sir, the Bandha University of Agriculture and Technology extend a sincere gratitude and a formal thanks to you to accepting our invitation, and of course to deliver this lecture with very informative and timely. Thank you very much, sir.
Thanks a lot. Thank you. Bye.
Thank you, sir.
So to all the participants, the next session, as I earlier mentioned and has already been communicated to you, would start at 12. So, and that is on high impact research publication by Dr. Mohammad. That is the next session. We may take a small break of around 20 minutes, and we will reassemble here, at 11:50 or 11:55. Thank you very much.